All right, so when we're looking at this figure to start off with, we're starting off with just a quadrilateral. And a quadrilateral is a polygon with 4 sides. And you need to know what a polygon is. That's a closed figure with sides. And you need to know what it means to be closed, meaning that we can trace our pencil around it once, and that there's no vertex with more than 2 sides of the shape meeting at it. So we think about what is or what is not a polygon. When we talk about it having sides, that means no curves. So a quadrilateral is a 4-sided polygon. Okay. When we talk about our first special polygon, we talk about what we like to call a parallelogram. And when we talked about parallelograms originally, 1, 2, 3, 4, 5, 6 characteristics, features, ways of proving, we kind of lump them all into one. So if you don't have them listed, go ahead and see if you can think of them now. What 6 characteristics of parallelograms, and being able to make yourself list them each time is how you remember them. When I give you your test paper tomorrow, next class, you should be able to like, oh, snap. 1, 2, 3, 4, 5, 6, list them all and have them memorized. I'll give you a second. All right, so there's mine. Now, what I want to be careful about, and some of you messed up on this for your quiz, when I talk about 2 parallel sides, that's not what I mean. I mean 2 sets of parallel sides. There are 4 sides total, and I need to have 1 set of parallel sides and then a second set of parallel sides. So make sure that you understand that. If that's new to you, make sure you write sets of, so that if your shorthand isn't helping you out, you need to make sure that you add more details. 2 sets of opposite congruent sides, 2 sets of opposite congruent angles, bisecting diagonals, consecutive supplementary angles, and 1 set aside that is both congruent and parallel. So we'll go ahead and add some markings to our parallelogram here. I know that my diagonals bisect. So when I look at this information, I know that these diagonals are not the same length, but I do know that this point here is the midpoint of them both. Okay? I know that by definition, this side and this side are parallel, and then these 2 opposite sides are parallel. I also know that these opposite sides are congruent. And I also know that these opposite angles are congruent. Now, nobody said anything about this diagonal bisecting this angle. That doesn't happen all the time in a parallelogram. But let's make sure I have everything I have listed. 2 sets of opposite parallel sides, I've got that listed. 2 sets of opposite congruent sides, I've got that listed. 2 sets of opposite congruent angles, bisecting diagonals. The only thing I don't really have here is that consecutive angles are supplementary. So I might want to make sure that I make a note of consecutive angles are supplementary by adding to 180 degrees. And it has to happen in both directions. So this angle is consecutive with this one and this one. This angle is consecutive with this one and this one. So it has to happen both times, and that's what rules out trapezoids a lot of times. All right, so when I have my parallelograms, my next step is to go ahead and talk about my special kind of parallelograms. And my first one I'm going to talk about is my rectangle. Now, what's interesting is I don't need to rewrite a single one of these things because I know that my rectangles, my squares, and my rhombuses all embody all the parallelogram. So the only thing I'm going to add to my rectangle is stuff that's unique to my rectangle. Your rectangle is equiangular. So every single one of those is a right angle. Your rectangle also has congruent diagonals. So yes, they're bisected, but guess what? They're also going to be congruent. So I'm going to make a note here about congruent diagonals. Everything else is true. Opposite congruent angles, opposite congruent sides, opposite parallel sides, bisecting diagonals, supplementary consecutive angles. That's all still true. The only thing that's new with rectangles is equal angular and congruent diagonals. All right, with the same thing in mind, I can come on over here and I can talk about my rhombus. When I talk about my rhombus, my blue pen is going to work. When I talk about my rhombus, where this shape is equal angular, this shape is equilateral. So I want to make sure that I mark that. I want to make sure that I mark the fact that these diagonals are perpendicular. And then I want to make sure that I mark down the fact that each of these angles is bisected. And this becomes an important conversation because it's important to recognize what is congruent and what is not. These angles are not necessarily congruent, but these are congruent because those diagonals bisect. So my opposite angles are congruent, and then each of those opposite angles is bisected. What's important when we talk about a square is the square is the big daddy that incorporates everything. Everything from the rectangle applies to the square. Everything from the rhombus applies to the square. Now, if you want to go through and make all those notes again about congruent diagonals and bisected angles and perpendicular diagonals and equal angular and equilateral shape, go ahead and mark it up. Would you please turn to your group and talk about what characteristics you missed and what you were able to include when you talked about it? Go. All right, come back. Now we're going to talk about quadrilaterals that are not necessarily parallelograms. And our first one we're going to talk about is our trapezoid. And the defining characteristic of a trapezoid is it has exactly one set of parallel lines. If it had two sets of parallel lines, it would be a parallelogram. I want to make sure that you remember about the mid-segment. So our mid-segment is going to be that segment that connects the midpoints of each of the legs. And make sure that you know the mid-segment is equal to the average of the bases. So if I add base 1 plus base 2 together and divide by 2, I get the length of my mid-segment. And nobody cares which one is base 1 or which one is base 2, as long as you remember your parallel sides are your bases. So your non-parallel sides are the legs, and your parallel sides are the bases. Nobody cares whether the shorter or the longer one is going to be base 1 or base 2. If we have a special kind of trapezoid, we know it's isosceles. And our isosceles trapezoid is going to have congruent legs. It's going to have congruent base angles. The other thing that's unique about the isosceles trapezoid is it's guaranteed to have congruent diagonals. All right, our last shape over here is going to be exactly what it looks like, and that is a kite. What's special about a kite is they have two sets of sides that are congruent, but they are consecutive sides. And that's what keeps it from being a parallelogram. A parallelogram has opposite congruent sides. A kite has consecutive. Consecutive means next to each other. It also has our perpendicular diagonals. It has one set of opposite congruent angles, and the non-congruent angles are bisected. So that's a little bit confusing. These angles are not bisected. These angles are not congruent. So make sure you understand those markings carefully for our kite. All right, with your group mates, talk about what you missed for kites and trapezoids. And your markers that go. So we want to include our concave shape here, which is our dart. It is a quadrilateral that it's concave, where it dents in. Think about it like that. If there's a case where your dart has consecutive congruent sides, we can call that a concave kite. So if it's a quadrilateral that's concave, we can call it a dart. And if it happens to have consecutive congruent sides, then we can call it a concave kite. Sound okay? All right, now I want you to flip over to the other side, because the other side is kind of fun. What happens on the other side is this. You can't go by what you see. So for example, everybody thinks that this is a parallelogram, a square, a trapezoid, but the markings on each of those shapes does not say that. So what I need you and your groups to do is forget what your eye is telling you it is and go with what your brain sees. So for example, if I have two sets of consecutive congruent sides and perpendicular diagonals, what must this shape be? This is a kite. So what's interesting is I always hope that nobody's walking by looking at the pictures and hearing me call this a kite, because they'll be like, boy, that lady doesn't know what she's talking about, does she? That's definitely. So don't go by what your eye says. So with your group, here's how I want you to approach this. Talk about what you see. I see two sets of consecutive interior, or two sets of consecutive congruent sides. I see perpendicular diagonals, so therefore it must be a kite. And I just saw Cadence do what I love to see, the flipping back and forth, because all of the information that you need, by no small chance, is on the other side. And your mark it, set, talk. Let's check our work and see how we did. 1, 2, and 3 I have as a kite, a parallelogram, and a parallelogram. So if all I have is bisecting diagonals, I can't go one step further and say whether it's a rectangle, a square, or a rhombus. I don't have any additional information. All I'm left with is parallelogram. It's not a trapezoid because the trapezoid's diagonals don't bisect. Number 3 looks like a trapezoid, but because I have one set of sides that's both congruent and parallel, I know it has to be a parallelogram. All right, you ready for 4, 5, and 6? You ready? So when we look at each of these shapes, I have a rhombus, a square, and a parallelogram. This one has to be a rhombus because its diagonals are bisected but not congruent. Check out your markings. If everything just had a 1 marking on it, then I would know that it had to be a square. My diagonals are perpendicular, so that's going to be a rhombus. Now, yesterday some of the classes had a hard time with this one being a square because they're like, but it's not boxed. I'm like, yeah, but they're congruent. So if I have congruent supplementary angles, I know then that they are 90 degrees. So that is definitely a square. Parallelogram, by definition, 2 sets of opposite parallel lines. All right, ready for the next? 7, 8, and 9 are a kite, a rectangle, and a rhombus. Our kite has consecutive congruent sides. A rectangle is a parallelogram by my parallel markings, but I have a right angle there, meaning they're all going to be right angles. This one's got to be a rhombus because my diagonals are bisected. If I know that these 2 angles have to be congruent, then I know that this one and this one have to be the same. Therefore, I get a bisected diagonal. Therefore, I get a rhombus. Ready for the last 3? 10, 11, and 12 are a trapezoid, a rectangle, and a rhombus. How did you do? Okay? Anybody want to talk about any of them? Questions? Okay. All right. So in a minute we're going to go over your homework, but first of all, what I'd like to do is I'd like to talk about how we can go ahead and figure out the area. Lots of kids frustrated about, why do I have to memorize, blah, blah, blah. But I want you to see that if you understand the one basic formula for area is equal to length times width, that can be applied to every single one of these shapes. So we're going to talk about each of these now in terms of area, and I want you to take the time to write down the area formulas on each shape, please. If I have a square that all of my sides are the same, I can still do length times width for the square, but they just happen to both have the same measure. So you don't have to memorize side squared. You can still think about length times width because that's going to work here, but you're going to be actually squaring that side because if it's a square, it has 2 side lengths that are the same. If it's a parallelogram, I need to kind of put it back into terms of using right angles to determine how many squares fit in it. And the coolest thing about a parallelogram is if I were, imagine yourself just making it stand up straight, then this height and this base are going to represent that length times width. So we know our area is base times height, but if you want to think of it as length times width, you can, just as long as you're sure that that height that you're measuring is the perpendicular height of that shape. So when we're talking about a rhombus, if I have the height and the base, a rhombus is a special kind of parallelogram, so you can use that too. The second possibility that we gave you for measuring area of a rhombus is I want you to picture gift wrapping it in a box and giving it to your best friend for her birthday. Doesn't everybody want a rhombus for their birthday? Because I have my diagonal 1 and my diagonal 2, I can go with that same idea of area being diagonal 1 times diagonal 2, which is my length and my width, except for think about all of that space that I don't have included. And we can talk about all of this space in the box that you would need to fill with tissue paper that's not included. So whether you think of that as area is equal to the product of the diagonals divided by 2 or 1/2 times the product of the diagonals, that's fine. Now let's say that you gave your friend a rhombus last year for her birthday. So now this year, you're going to give her a kite because the kite philosophy is exactly the same. That kite fits in a box that's twice its size. One diagonal times the second diagonal is the area of the box. The area of the kite is 1/2 the product of the diagonals, or you can think of it as the diagonals divided by 2. When we talk about trapezoids, this is my favorite one because with the trapezoids, you can picture yourself taking this top part of the trapezoid, that slice off, and flipping it around and adding it on. So think about this part here. If we sliced it at the mid segment and spun it around, this here is base 1. Picture it spun around with this slant. So then I know that my area is going to be 1/2 of the height, which is how tall my parallelogram is, times the sum of the bases. Because here is my height of my trapezoid, 1/2 of the height times the sum of the bases. If you think about switching that area over. Now the interesting thing here is we haven't talked about triangles yet. So if we take a trapezoid and instead of dividing it and making it into a parallelogram, I want you to think about making it into 2 triangles. Do you see my green triangle? And do you see my orange triangle? My green triangle, if I make this base 1, my area is 1/2 times my base times my height. The area of my orange triangle is also 1/2 times its base times its height. If I were to factor out a 1/2 and a height, I would end up with 1/2 height times the sum of the bases, which is no surprise. That's the same thing I had up here. So when we go to find area, I know I have every single triangle is 1/2 of a rectangle. And every single one of these shapes can be linked back to that basic length times width. All right, let's take out your homework then from last class. All right, so here's what I'm going to do. I'm just giving you the answers today. I'll post all of my work on Schoology. So if my answers don't match yours, you can always go back into Schoology and you can look at and let me know what it is you don't understand or you want to go over. If you're a friend that doesn't have the homework done, what I recommend that you do today is just copy down my answers and then go back and do the work again to make sure that you know how to get these values The first 6 are not tricky at all. So those answers should have been easy. Just looking at each of my basic quadrilaterals and how to find the area for them. 3 was a little backwards. They gave you the area, you had to find the height, no big deal. When we talk about 7, 8, 9, 10, 11, and 12, those are definitely tricky because you had to dig into your trig pocket. So you had to, for number 7, you had to first figure out what your length and width of that triangle was. And you don't have it, so you had to do the sine of 33 degrees to get your height, and you had to do the cosine of 33 degrees to figure out what your base was, given that hypotenuse of 14. 8, you had to do Pythagoras, a squared plus b squared equals c squared, to be able to solve for that b side, which is your height. 9 is very similar to 7, except now I've got a 37-degree angle. So you had to use sine and cosine to find your base and your height. Number 10, you have your base, but you need your height. So you had to use tangent for number 10 to find that. Number 11, nobody needs this information, so that doesn't matter. We just have to use tangent of 35 degrees to figure out your base, given your height. And 12 is tricky because you need to deal with each triangle separately. And then once you find your height here by using the sine, you need to use your inverse trig to calculate the angle, given the sine of x is going to be the ratio between these. So those ones were definitely tricky. Make sure the first time you're trying them isn't when you're taking the test next class. Trapezoids, you can go ahead and draw a vertical side here. Lots of kids messed up on this one because they assumed they were left with a square, and nobody ever said that this was a square. If you notice, you get a special right triangle here. So if this is 10, this is 5, and this is 5 roots of 3. So you can do some subtraction to get rounding to the nearest 100 is our rule of thumb, For this second trapezoid here, you again need to use some Pythagoras to figure out what this side is to use for the height. For our rhombi in number 14, because I know the diagonals are bisected, since this was 10, that means I got a 5 and a 5. So when I go to draw my second diagonal, I've got right triangles here. So a squared plus b squared is c squared to help me figure out those lengths of those diagonals. For our kites, 1/2 the product of the diagonals. And then 16 and 17 when it's not drawn out for you. So if those were tricky for you, check out the key on Schoology. And that's where I take the time to write out all of my calculations. So you can look there. Sound okay? All right. Awesome.